So how do we learn? And why do some of us learn things more easily than others? Can't you learn anything you choose to with ease? Why do our kids sometimes fail in school? Why, as we age, do we tend to forget things? And why don't people fully recover from brain damage? We used to think that after childhood, the brain really could not change. And it turns out that nothing could be farther from the truth. Another misconception about the brain is that you only use parts of it at any given time, and it's silent when you do nothing. Well, this is also untrue. It turns out that even when you're at rest and thinking of nothing, your brain is highly active. So it's been advances in technology, such as MRI, has allowed us to make these and many other important discoveries. And perhaps the most exciting, the most interesting and transformative of these discoveries is that every time you learn a new fact or skill, you change your brain. It's something we call neuroplasticity. So what does it look like? So your brain can change in three very basic ways to support learning. And the first is chemical. So your brain actually functions by transferring chemical signals between brain cells, what we call neurons, and these trigger a series of actions and reactions. So to support learning, your brain can increase the amount or the concentrations of these chemical signaling that's taking place between neurons. Now, because this kind of change can happen very rapidly, this supports short-term memory, or the short-term improvement in the performance of a motor skill. The second way that the brain can change to support learning is by altering its structure. So during learning, the brain can change the connections between neurons. Now here, the physical structure of the brain is actually changing, so this takes a bit more time. These types of changes are related to long-term memory, the long-term improvement in a motor skill. Remember that long-term memories take time, and what you see in the short term does not reflect learning. It's these physical changes that are now going to support long-term memories and chemical changes that support short-term memories. Structural changes also can lead to integrated networks of brain regions that function together to support learning. And they can also lead to certain brain regions that are important for very specific behaviors to change their structure or to enlarge. And so here's some examples of that. So people who read Braille, they have larger hand sensory areas in their brain than those of us who don't. Your dominant hand motor region, which is on the left side of your brain if you're right-handed, is larger than the other side. And research shows that London taxicab drivers who actually have to memorize a map of London to get their taxicab license, they have larger brain regions devoted to spatial or mapping memories. Now, the last way that your brain can change to support learning is by altering its function. As you use a brain region, it becomes more and more excitable and easy to use again. And as your brain has these areas that increase their excitability, the brain shifts how and when they're activated. With learning, we see that whole networks of brain activity are shifting and changing. So neuroplasticity is supported by chemical, by structural, and by functional changes. And these are happening across the whole brain. They can occur in isolation from one another, but most often they take place in concert. Together, they support learning, and they're taking place all the time. So I've just told you really how awesomely neuroplastic your brain is. So why can't you learn anything you choose to with ease? Why do our kids sometimes fail in school? Why, as we age, do we tend to forget things? And why don't people fully recover from brain damage? That is, what is it that limits and facilitates neuroplasticity? So the first lesson is that the primary driver of change in your brain is your behavior. So there's no neuroplasticity drug you can take. Nothing is more effective than practice at helping you learn. And the bottom line is, you have to do the work. And in fact, my research has shown that increased difficulty, increased struggle, if you will, during practice actually leads to both more learning and greater structural change in the brain. The second lesson we've learned about the brain is that there is no one-size-fits-all approach to learning. So there's no recipe for learning. Consider the popular belief that it takes 10,000 hours of practice to learn and to master a new motor skill. Now, I can assure you it is not quite that simple. For some of us, it's going to take a lot more practice, and for others, it may take far less. So the shaping of our plastic brains it's far too unique for there to be any single intervention that's going to work for all of us. And now this realization have forced us to consider something called personalized medicine. And I believe we have to consider not just personalized medicine, but personalized learning. The uniqueness of your brain will affect you, both as a learner and also as a teacher. And now this idea helps us to understand why some children can thrive in traditional education settings and others don't. Why some of us can learn languages easily, and yet others can pick up any sport and excel. So when you leave this room today, your brain will not be the same as when you entered this morning. But each of you is going to have changed your brain differently. Study how and what you learn best. Repeat those behaviors that are healthy for your brain, and break those behaviors and habits that are not. Practice. Learning is about doing the work that your brain requires. So the best strategies are going to vary between individuals. You know what? They're even going to vary within individuals. So for you, learning music may come very easily, but learning to snowboard, much harder. Understand that everything you do, everything you encounter, and everything you experience is changing your brain. And that can be for better, but it can also be for worse. So when you leave today, go out and build the brain you want.